So in this video, what we will be looking at is rewriting this quadratic expression in this form by completing the square. And this is just a standard way of writing a quadratic expression. And so we actually be doing that today. Let's see. Let me change the color of my marker. So we have a open bracket x plus h close bracket raised to the second power plus a constant k. And it is so easy. And if you actually remember how a quadratic expression looks like, this is a general form of a quadratic expression where this term represents this. As you can see, this coefficient is the coefficient of the x and the x square. The x square, you can see the 2 representing the x as a coefficient. We have the b representing this 8 as a coefficient of the x, and the variable x is there. And c is just a constant, just as is constant 10. And so we are actually using this concept because this quadratic expression can be written in the standard form. And if you can actually look at the standard form, it could be worked out or in an expansion form to give you back a quadratic expression. And so we'll be looking at that concept today. We'll be looking in depth. We could actually predict what our answer will be by having just a quadratic expression. And so before even rewriting into that form, we could actually predict what our answer will always be based on just a representation. But let's go into the simple part of it. So the first step we take is to factorize all of this term by the coefficient of the x square. And so what we will do, we will take that 2 out and factorize each term. 2 into 2x squared gives us x squared. And we said 2x squared, we said 2 into 8x gives us 4x. And then what we now want to do is to separate the x's from the constant when we're factorizing. And so, if I should say 2 into 10 goes 5 times. And so the second step we take is to half, this would be our new b coming from this. Because this is actually an equivalent or a reduced form of this quadratic. It's just being factorized. Oh, let me put a bracket right here, because everything in this bracket is being factorized. And if I were to actually bring back this factored expression to the original state of this, then remember I would have to distribute 2 to each term in this bracket. And so everything should be multiplied by 2, therefore I must bracket everything. So seeing that these are in parentheses because I am separating them from this constant. However, all of this term should be in bracket as they will be multiplying by this coefficient to get back the original thing. Alright, so let's go. So the second step we actually take is to half this b term and square it. That answer we get, we're going to add it in the bracket where the x's are, and also subtract that same number with the constant 5 outside. We always do that. So whenever you're writing a quadratic expression into the standard form, when we reach the factorized part, we always half this term and square it. The answer we get, we add that answer with these x's and we subtract it with the constant outside. So let's do one. Let's do it that you see. So half of 4 is 2, and the square. So 4 divided by 2, and then we're going to square it. So we say that gives us 2. When we square it, we get 4. And so the number that we actually get is 4. And so we'll say 2, right? This bracket, close that small bracket, plus 4x plus the 4 that we got. And let me use a different color to write this 4 so you can actually see that something special is happening right here. Close bracket. And then you can just write back plus 5, and I will just subtract the 4 from here. So any number that we add in the bracket, we subtract it outside. And let's see why we do this. Oh, all of this should be in bracket. Let me write this better than let's put a bracket right here. Oops. Now this is why we actually add and subtract the same number. Since we're factorizing this thing, if we were to go back to leave from here and bring it back to this one, this original quadratic expression, the only way that we'll have the same expression is that if we add something in the expression, we must add its inverse or its opposite to cancel it if we were to bring it back. So this expression would not be affected in any way, because if you add 1 to this expression, it will not be equivalent to the original expression. Therefore, if we add something, we subtract it. If we were to actually go back to the original expression, or we don't want to affect it any at all. The only way we don't affect it is if anything that we add, we apply the inverse of that same thing that we add. Or if we subtract something, we will just simply add the inverse of that thing. So if I add positive 9, if I add 9, I will subtract 9. If I add 10, I subtract 10. If I add 20, I subtract 20. If I had positive 30, if I add 30, I will actually subtract 30. So anything that I add, and that always comes from the term that you will always have and square. And so we always put that number, the number that we have and square, we always put it in the bracket where the x's are, and we subtract 1 outside with the constant. And so let's go. And if you should actually remember the previous video that we looked at in the introduction of completing the square, this expression right here is a completed square. This expression right here is a completed square. And so it can be written in the form of as this. It's a completed square. And if we should remember the video that we did, when we should actually derive, or to give you a clear picture of what does it mean by completing a square. All right, so what we're going to do now is to rewrite this in the form as this. And this is what we must always look forward to. Very simple. This a is going to represent that term outside. That was the coefficient of the x squared that we used to factorize all the terms in the quadratic. And so this x will always be this one of this x, one of this x squared. This x is always going to be one of, well, this is actually 2x being multiplied. It's going to be one of the x's. And so this h will always be half of this, or the square root of that. Always. And we just put this 2 right here. Now this constant is determined based on what the constants are outside. And we just actually do that right now. So let us simply write this in the standard form. So after having the expression looking at that, you are actually on your final way and the final step to solve it. So we write now a would actually be 2. So we say 2 outside and put this big bracket here. X close bracket plus half of 4, or the square root of 4, which is the same thing as 2. Raise to the second power, and then we work out what the constant is 1. So we actually have this in the standard form. If we were to prove that this is coming from this quadratic expression right here, we can prove it that this is coming from this quadratic expression. And so let's go ahead and prove it. To show that your answer can also bring you back to the solution. And so let's work this out. What would this be? This would actually be 2 outside. This will actually be this being multiplied by itself identically, just like an exponent, it's actually an exponent. Exponent, or you have an exponent, so it actually tends that we're multiplying by itself. So we have plus 1. Let me use a different color now. And so we're going to work out these identical brackets. And so we say, right, 2 outside, we have that bracket here. We say x times x gives us x squared. X times 2 gives us 2x. 2 times x gives us 2x. 2 times that gives us 4. And we have the 1 outside. How we do that? Well, I don't have to have so many brackets because I only have one long expression. I don't have to have 2 brackets, but that's okay. Let me bring this up some more. And so let's just simplify this expression. So we have 2 outside, we have in bracket, we have that. These 2 terms are going to be added. So we have 4x, and we're going to work out these constants plus 5. Now, if we were to distribute this 2 to each term in the bracket, we will get our final answer would be 2 times x squared is 2x squared, 2 times 4x is 8x, and 2 times 5 is 10. And this proves that this what we're doing is right, because we actually get back the same expression right there. We get back the same expression right there. We got it back right here. And so that's just simply it. The steps is very simple. We just factorize the coefficient of the x squared by each term, with each term, and then we halve the middle term. We half it, we square it, and then we add that value with the x's that are separated from the constant. Whatever we add in the bracket, we subtract outside, and then we write this in the standard form. How do we do that? We have our coefficient outside, and what we do, we put an x in the bracket, then but based on what number is there as a middle number or b, then we'll actually have half of that, or the square root of the number that we square, right? And so we'll actually add the constants with it. So we could actually look at something different. We could use the same example and to predict what our answer is always going to be. So let us try it. Let us erase this thing and see. Let us look what our answer, what we got for the answer. We got for answer, let's see. We got 2 outside, open bracket, let me see. Right, 2 outside with a bracket and parentheses, x plus 2 raised to the second power plus 1. That's what we got. We can actually predict what our answer is going to be. So let's just erase this and do something very fresh. We can predict, because this is what the answer will always be in this form. The answer will always be in this form. Look, everybody pay attention. So look at this now. The cons will always be this. You're always going to have a coefficient outside, or a number that will be multiplied by everything inside. Okay? And so we have, let's say you have a bracket looking like this. We're always going to have an x right here. Let me just let's use this parentheses. We're always going to have an x looking like that. Always. And then what is going to be, well, you can have either a plus or a minus right here. So this is just a standard form, the prediction of the standard form. What your answer will be in the standard form, coming from the quadratic expression. And so what is always going to be here is half of b is going to, whatever b is, after factorizing it with the coefficient of x squared. This term is always going to be right here, half of b, or the square root. The square root of the term that you square. So it'll always be. And we actually close this raised to the second power plus the constant minus the number that you subtract after halving it and squaring it. Your answer will always be in this form. Let us see. What was the question we had? We had 2x squared plus 8x plus 10. Now we predict that 2 is always going to be right. Well, whatever the coefficient of x is that a will assume that that number will assume the position of the a. Now, so we're going to have then 2 outside. What is going to be here? X is always going to be here. What is going to be right here? No, not this b, not this b, but the b that is factorized, which was 4a, which is 4x. And so that 4, you have half of it right here, which is 2. You write your square, And what is going to be outside as this? Now, when we factor 10, we get 5. We got 5 right here. What we got here, we got 4 right here when we half it and square it. And so if we have 5 minus 4, we actually get 1. And so we can predict that our answer will always be in this form. We can predict what our answer is going to be before we finish it. Let's do one. Let's say we have 4x squared plus, let's say 16, let's say 8. So we can predict what our answer is going to be. A is going to be 4. We know that. We're going to have an x. When we factor this by 4, we're going to get 4. And so half of 4 will be actually be 2. For that there, we're actually predicting it. Because we're going to have this there. When we factor everything by 4, this term is going to be 4. Half of that's going to be 2. Because this will be our new, the factorized answer for this will be 4, and that will be our new b. That is a b that we're going to have. That is going to be here. And so what is going to be here? When we factor 8 by 4, we will get 2. And so if we get 2 for that, what is the number that we're going to have and square? We're going to have 4, we get 2. When we square it, we get 4. And so for the constant, we will get 2 minus 4. And this will give us a negative 2. So our answer is going to be like this. This is a prediction. Let's see if this is correct. So our answer should be 4 over bracket x plus 2 raised to the second power minus 2. Let's look at it. Let's just follow the steps. So let's just follow the steps. First step, step number 1, we factor this quadratic, because we're actually writing it in this form, this standard form. So what we're going to do is to factor, this would be a k. What we're going to do is to actually factorize this expression by the coefficient of x squared. So my 8 is right here. So let's say we factor this by, so we say 4 is outside, and we say x squared plus 4x, separate that from the constant, and the constant, well, we got 2. We just put a big bracket right here. And so what we're going to do is to halve this and square it. And so we have now 4x, that plus 4x. When we have 4, we'll get 2, and when we square it, we get 4. So we had 4 there. Plus 2 minus 4. Let's go. Right over 4 outside. And we have one of the x's. We're going to have half of this here, or the square root of that, which is 2. All square. When you work this out, we get negative 2. There you go. We actually predict what our answer was going to be. And so it doesn't matter what quadratic expression you got, you can actually use that concept to write a quadratic expression in the standard form by actually completing the square. And this is what we actually complete the square by. So this can be a complete square. It's actually a complete square, because a complete square is just simply a number that you multiply by itself and it gives you an answer, and that answer will be a completed square number. And so like for argument's sake, if I have 2 raised to the second power, it's gonna be 2 times 2 equals 4. So if I have this raised to the second power, that is just the same concept, multiplying by itself to get a squared number. And so that's it. But it doesn't get a number when we have like fractions in it, because sometimes we're gonna have fractions in the concept, and it can be a little more. It takes a little more time than actually factorizing an expression by an even number when you have a lot of even numbers in the expression. But what about when you have even numbers and odd numbers in the expression? Then you will probably have a fraction. Like say I have 3x squared plus, let's say 5 x plus, let's say 1. No, we don't have any. If we should factorize, we are always factorized by the x squared. We always by the coefficient of the x squared. So when we take this 3 out, we actually have x squared. And we say since 3 is not a factor of 5, then we will actually divide this by 3. Close that. Well, let's close that. And then this one is going to also be divided by 3. And why do we do that? Let's look. Remember, if we were to actually go back to the original quadratic expression, if I should multiply this 3 by each term, it should give me back 3x squared plus 5x plus 1. Let's see. If I should say 3 times x squared, it gives me 3x squared. If I should say 3 times 5 over 3x, it will give me back this 5. Because if I take 3 and times it by that, this 3 cancels that 3 and it brings me back to this original term. So it will give me the same thing if I should multiply this 3 by this 1/3. This 3, the 3 will be cancelled with the other 3 and 1 will be left. And so what we do here now, let me write back my square right here. Oh, that's okay. And so the other step is now, and this is the part where most students don't like. When you actually have a fraction and you have to half it and square it. But this is so simple. Any fraction that you're going to half, always multiply that fraction by a half. And let's look. Let's say I'm going to have the middle term, which is 5 over 3. So I'm going to say, let me use a different color. 5 over 3 divided by 2. And so in primary school, we learned that we could actually rewrite it like that, like this. Create a fraction right there, and then we could actually, the concept that we say, we actually key the first fraction, we change the sign to the opposite, and then we invert this or find the reciprocal of that fraction. And so actually you're seeing that it is being multiplied by a half. So whenever you're actually dividing a fraction by just 2 or 3, you're going to multiply it by 4, just multiply by a quarter. You're going to multiply by 3, multiply by 1/3. If you're going to multiply by 2, just multiply that fraction by a half right away. And so we're going to say these fractions cannot be reduced. And so we'll just go ahead and multiply them as they are. So we say 5 ones gives us 5, and 3 2 gives us 6. And so we can actually, that's when it is half. When it is half, it is actually 5 over 6. And now if we were to square this fraction, we'll actually, based on the laws of indices, when you have a fraction in a bracket and it is being raised by an exponent, we always distribute the exponent by each term in the bracket. So we'll say the square of 5 is 25 and the square of 6 is 36. And so that's when it is squared. And so what we're going to do now is to add this fraction with the x's and subtract this fraction outside with the constant. So let's go. So here we go writing it now. So we have 3 outside, put this bracket there, x squared plus the same fraction, and we add 25 over 36, close bracket. We have 1 plus 1/3 minus 25 over 36. And this is so easy to understand. So this is no big deal. It might look like it is very confusing, but it is not. If you remember fractions from lower school and primary school days, you won't have any problem with this. So just work with fractions. All right, so let's go. So we're going to take our time. I'm going to write it now in the standard form. So we write our x there, and then we're going to write half of this, which was what we got. We got 5 over 6, close bracket, raised to the second power. And so we're going to work this out now. So we can actually change this to an equivalent fraction that resembles the same the same denominator as that fraction. So what we could actually do is to multiply this fraction by 12, the denominator and also the numerator. So we can have 36 as a common denominator in this fraction, because it is easier to add and subtract fractions when they share the same denominator. And so what we'll do actually multiply this by 12. And so we said 12 ones gives you what? 12. And we say 3 times 12 gives us 36. We just write back the original fraction that we had. So we have common denominators. So if we should subtract the numerator, since the denominators are the same, we just take back one of the denominators. So we take back one and write a different color. So we take back one of the denominator. Well, we have, I hope this is at negative 13 would be the numerator, while 36. And so we actually write this in the standard form, where we have a as the we have x representing a outside, and then we have x there. This represents h. The square is there, and this fraction where we have this should supposed to be negative, not positive, because when a negative and a positive, when they are clashing, the negative is stronger. So this operation should be a negative. So we have a negative 13 over 36. And so this constant actually represents this. And there you go. Writing a quadratic expression in the standard form, a open bracket x plus h raised to the second power plus k. What are the steps? We factor the coefficient of the x squared, and then we separate the x's from the constant. When we do that, we have to factorize the new bx, which is in the factorized form. We have that, we square it, and when we square it with the half, then square it, we add that value with the x's and we subtract one outside. And then what we do, we just write that, we just simplify that expression. We write it with we put the constant, we put the coefficient outside, which represents x. We represent a, and then we write the x in the bracket, and then we write now half of whatever the new factorized b is. We close it the bracket, we raise it to 2, and then we simplify the constants outside, and there you go.